Good morning, all. We'll go ahead and get started. Our speaker for this talk is Everett Moss, a software engineer at Microsoft for the last 4 years. He will be giving us a talk on security tooling, so go build a tool. A little bit about Everett. There's a rumor going around that he has created over 100,000 work items, and it's not yet been proven. Coincidentally, anyone that has tried investigating this a bit further finds themselves with a couple of security items that are urgent, and so their attention is redirected back to working those security items. So he will give us a quick talk on how to create tooling, and let's save our questions to the end of his talk. Do you use social media responsibly? And please turn off your cell phones. Thank you. Take it away.
All right. Can everyone hear me? Yes? No? Good? Okay, so this is Go Build a Tool. If you're looking for a different talk, it's probably in a different room. But please stay. I hope that this talk will be good. Anyways, my name is Everett Moss, and we'll start with a little bit about this talk. This talk's aimed at security experts, not current tool builders. Honestly, if you already have a lot of experience building tools, although what I'm going to say might frame common things that you know in a new way, you're not going to learn much new. This talk is going to be focused on best practices. My goal is not to get into really the details of how to implement a static analysis tool or a dynamic analysis tool. My hope is that you can learn that yourself. I'm not going to be talking about things like new ways to do abstract interpretation. What I am going to be talking about is how to make sure that when you build a tool, well, one, why you should build a tool, and then two, how to make sure that when you build a tool and when you roll it out to an organization, that's successful. I'm going to be basing this both on my own personal experience and anecdotes from around Microsoft, and also a lot of research papers that I went and read in preparation for this talk. So here's a brief overview. First, we're going to talk about why you should build security tools at all. If there isn't a reason to build security tooling, then it really doesn't make sense to do the rest of the talk. Then we'll get a little bit into types of tooling. Just so that we're all on the same page around what I mean when I say a static analysis tool or a dynamic analysis tool. And then also I'm introducing a sort of a new term for process tools, which I'll get to in a little bit. And then the meat of the talk is going to be a lot of best practices for building static and dynamic analysis tools and rolling them out across organizations, as well as a series of case studies from Microsoft illustrating some of the points that I make. But before that, who am I to tell you these things? My name's Everett Moss. I've been a developer at Microsoft for about 4 years. All of that time has been spent working on security tooling or security tooling rollouts. So this is kind of my bread and butter. I work on BinSkim, which is an open source binary checking tool that Microsoft has released on GitHub. And I've also worked on a bunch of internal Microsoft tools with names like ASA, Modern Cop, and DBScan. Additionally, I also was the technical lead for an internal Microsoft project called TSA, which basically aggregates security analysis results. So that gave me a lot of experience with tool rollouts across groups like SQL, Azure, and Bing, as well as others. So, and some brief acknowledgements. I'd like to thank Michael Fanning, who is not in the audience, I don't think. He's my manager, and conversations with him really helped me get a good sense of what I wanted to say with this talk. He also gave me some very valuable feedback on early versions of the slides. I'd like to thank Graham Calladine, with whom this talk would not be happening. He kicked me in my ass last year and asked me why I wasn't presenting already. I said, hey, it's my first BlueHat, cut me some slack. But that gave me the confidence to put together a talk for this year. I'd also like to thank my team, which is the Microsoft One Engineering System Security Tools team. They were great at listening to an early version of this talk, giving me valuable feedback, and telling me that I did not have enough pictures. So, why tools? So there's this new idea of DevSecOps, which some of you may have heard. But really what it boils down to is, if you read the 2018 State of DevOps report, organizations are shipping faster than ever. Some of the highest performing organizations ship multiple times a day, and that's certainly true at Microsoft, and I hope it's also true at your organizations. At the same time, security expertise is really rare. The numbers I've been able to find are about one security expert per 100 developers. And if you think that you're going to be able to review all of the work that those 100 developers are doing and shipping every day for security vulnerabilities, you are just quite frankly mistaken. So tools just give us a chance to automate all of that. They give us a chance to lower the amount of work that you need to do as a security person, but also they give you a chance to power up developers. If you make a good tool and the tool finds a bug, say a SQL injection vulnerability, that then teaches the developer not to make that mistake again. And that particular thing is why I think tools are really valuable, because they not only automate the process that you have to go through as a security expert, but they also allow you to flow some of your knowledge back into the development organization and really just improve the developers so that your work gets easier and easier, and you can focus on harder or newer bugs like, say, deserialization issues. So, hopefully you're convinced that tools are important. Let's talk about different types of tooling you can build. So the sort of clear ones are static and dynamic tools. Static tools look at artifacts without running them. So what does that mean? It means that they're looking at source code. They're looking at binaries. Static tools are really easy to scale out and really easy to integrate, because you don't have to know how to run a program to do it or how to set up an environment. They show the possibility of bugs. Thanks to the halting problem, they cannot definitively show you that there is a bug there. The proof for that's really easy if you want it later. I really like to think of these as automatic code review. They look at code, they say, hey, this looks like it might be a SQL injection vulnerability. Could you go fix that? Or, hey, it looks like you have a compiler problem here. You aren't compiling with the right flags. Could you go fix that? Dynamic tools, on the other hand, actually require running the code. A really common example of dynamic tools is fuzzing, but also I would lump web scanning and things like that into this category. This is just running the code and seeing what it does. It's pretty straightforward. The nice thing about dynamic tools is that they show definitively that there is definitely a bug there. If you run your program with a particular input and it crashes, that's pretty unequivocally a bug. But the downside to that is that you don't get the kind of coverage that you get with static tools. So you don't necessarily know that you've covered all of the paths of a program. You just know that you've covered as many as you've been able to test. One of the other thing that I'd like to talk about for a little bit is process tools. So this is kind of a new and developing category. And the idea here is automating the security process. So this is things like automating threat modeling, or for instance, creating a series of security work based on a survey that you take of the developers, or directing security teams' attention based on, you ask the developers, hey, are you implementing any crypto? And they say yes. Well, all right, go to get a better look at that. Whereas if they're just adding another API to their already existing web application, maybe you don't need to take as close a look there. So let's get into what tools should be. This section is going to really cover features that I think are important for the tools that you implement, regardless of whether they're dynamic, static, or process-based tooling. Tools should really be simple. A really common theme that you're going to see throughout this presentation is that simple tools are really well understood by developers, and developer trust in your tools and their results and the guidance that they're getting from them is going to be key in actually getting them to pay attention to the results and fix bugs. Simple tools are easier to write. It turns out that one of the most successful tools at Microsoft is a tool called Credential Scanner, which we'll talk about a little bit later. And it just uses regular expressions. And yet it's used almost everywhere in every part of the engineering system. I think they recently hit 9 million tool runs per month, which is an incredible number for something that's just run at one company. The other nice thing about simple tools is that they're easier to use and integrate. We'll talk about tool integration a little bit more later, but if a tool is simple to run, if it's just a command line executable, it doesn't have an installer or write to the registry or write a bunch of temporary files or things like that, then it's going to be much easier to integrate that into an arbitrary build system. So that is, in some ways, something that you're going to need to keep in mind, is that simplicity is not necessarily easy. Finding ways to work around the registry and around temporary files, especially if you're talking about things like archiving, is not necessarily a trivial thing, but it does make your tool simpler to integrate. Tools should produce repeatable results. You really don't want to be having this type of argument with your developers. Developers really, the first thing that a developer is going to do when they get a tool result is try to reproduce it. They're going to want to be able to run your tool. They're going to want to be able to get the same result that you're saying you got with it, and then they're going to try to fix it, and then they're going to want to run your tool again and see that the problem went away. If your tool can't do that, it is, in my opinion, almost worthless. Coverity also, in their paper 1 million lines of bugs later, or 1 million lines of code later, if it's C++, it's 1 million bugs later as well, says that they completely forbid the use of non-determinism because it causes reproducibility problems like this. And they only use timeouts incredibly sparingly for the same reason. Now, I think that that's a little bit of a hard line. Non-determinism definitely does have a place, as do timeouts, but you should make it so that your timeouts are ideally based not on time, but on number of steps taken, and your output should be sufficient to reproduce it. So, for instance, if you're a fuzzer, non-determinism is built into the strategy, but you're going to want to provide the reproduction case for when you find a crash, so that developers can actually debug that. Tools should inspire action. Look, every time you file a bug, every time your tool finds something, every time it reports something, that's an ask for the developer to go fix something. If you do that too often, and if you do that spuriously, one, you'll annoy the developers, and we'll talk about that later. But assuming the developers are perfect and they really trust your tool, they're going to be going and making code changes, and that introduces risk. So if there isn't a desired change, your tool shouldn't output a result. This is really something this is a pet peeve of mine, is that even some of the best tools that Microsoft and the industry have built still can't differentiate between test code and shipping code. And it's not a trivial problem, but if you're filing bugs for test code, that is going to lead to a lot of churn and not necessarily valuable code changes. Tools should produce triageable results. Look, The developers that are going to be consuming your tool results are really coming from all sorts of different backgrounds. We all, I hope, know what we're talking about when we say, hey, SQL injection vulnerability or deserialization bug. But that doesn't mean that the new college hire down the hall is necessarily going to know what those were. I certainly didn't when I started at Microsoft. So the documentation as to what your tool's reporting and how to fix it really must be as clear as possible. Things like remediation examples, the severity of the issue, all sorts of things. And why the bug is why it's a bug in the first place are all important. And this is really just, I hope your developers aren't all like that, because then security experts wouldn't have a job. So let's do a case study. 1CS. Who here has heard of 1CS? Some Microsoft people, I assume. This is a Microsoft internal tool. And I really like this. This is a process tool. So what it does is it basically it asks a bunch of questions about what the application you're building looks like, and goes and then creates a bunch of work items for you to go knock out. And the work items that they create are really detailed. This wasn't always the case. There were a lot of pre-1CS solutions to this problem at Microsoft, and there were old bugs. So you probably can't read this, but this was the entire text of a bug that I found. It basically says, go run this tool. That's not the most helpful. Where's the tool? How do you run it? How do you look at the results? All of that isn't present there. You can compare that to an example of the new 1CS bug with a couple things blacked out. Those are all just Microsoft internal details. You probably can't read it, for which I apologize. But it basically says, hey, if you're doing this, then you need to go do exactly these steps. If you are running C# code, you need to run this series of tools. If you're writing C++ code, you need to run this series of tools. Things like that. And then here's a way that you can automate all of this tool runs, and here's a bunch of links to that documentation. So that's sort of the important thing to take away from this, is that the first sort of result, although these two things are basically the same ask, go run some tools. The second is going to get the right action from your developers a lot more often. So here's more about what tools should be, but I'm honestly making this its own section because this is a pet peeve of mine, and there's a couple points within it. So it's near and dear to my heart, as I'm a software developer and I would like your tools to respect my time. All right. You really need to go where the developer lives. A note on my creative process, the text on this slide originally just said no more fucking dashboards. Look, if you create a tool and you require someone to go to a special dashboard to look at the results, you're doing it wrong. There's a couple reasons for this. One, it's another action that person has to take every day, which is another thing that they're going to forget to do every day. So either they check it once a month when they remember, or it's another 15 minutes of their morning, which is wasting their time, or they don't look at it at all, which is the most likely case. So that alone should mean you really need to be integrating things into where the developers are. Pull requests are a great place. Google has a system called Tricorder that they've written about in the communications of the ACM, as well as publishing some research papers on. And they do all of their inline static analysis in the pull requests. IDE views. If you can get into the IDE and display things in the Visual Studio error list or things like that, that's going to be so much faster to get fixed than if a developer has to go and check some dashboard somewhere weeks after they wrote the code and they've already lost context. And yeah, work items. Work items are great. They're honestly, of the three things that I'm listing here, they are the worst because they lose context. Developers lose context every time they move from one task to another. So if you file a work item, even if it's just right after the build from their integration into the master branch, it may be another day or a week before that work item is triaged and assigned. And by then, the developer who originally wrote it may be working on other tasks or other high priority things. It may not get assigned to the same developer in the first place. So it'll take much longer to get fixed. I know I jokingly said I file a lot of work items, and I have, but that's because they're an easy way to integrate, not because they're the best way to integrate. But really, just no more dashboards, please. A shameless plug. So it would be great. It would be great if it was easy to integrate into every engineering system. But even if you're just talking about a single version control system like Git, if you're talking about people who are doing development in GitHub and VSTS and I think Atlassian or something like that, there are others. And each of those is going to have its own integration model. There's a bunch of different work item tracking systems, Jira, TFS, GitHub issues. So it would be really nice if all of the tools that if you could just get all of that for free by using a particular output format. And in the nearish future, you should be able to. The team that I'm on at Microsoft is working on a cross-industry standard with Micro Focus and Semel and a couple of other companies to standardize on the static analysis results interchange format, or SARIF. This is an open standard via Oasis. And Microsoft has published an MIT-licensed C# SDK, Visual Studio Code, and Visual Studio viewers, and there's a lot more to come in SDK land and also viewer land. So hopefully, if you're writing a tool, you can utilize this standard to make it easier to integrate. So, and a word on shifting left. So I did say, get some bugs in the, get things into the IDE. It's great. That's not quite true. Getting things into the IDE is great if you can make sure that the tool is applied at a team level. If you're applying a tool at an individual level, developers stop using it. So what I mean by that is if everyone on a development team needs to go download your tool, install it, and then integrate it into their IDE, there's going to be the one guy who doesn't do it. It's probably me. I'm that guy. And that's sort of shifting too far left. The shifting left is an engineering systems term, but basically the further left you are, the closer you are to the developer writing code, and the further right you are, the closer you are to production. So tools really need to be applied at a team level. Google calls this out in their tricorder paper, and Maria Christofsis, who's an MSR researcher, did a wide survey of Microsoft software developers and found that team policy is one of the biggest drivers of why people use security tools and program analysis tools in general. So let's talk about why team integration matters. There's a Microsoft tool called DevSkim. It's great. It integrates well into Visual Studio and Visual Studio Code, uses regular expressions. It's a pretty simple tool, but it's actually reasonably accurate. It gives you a bunch of quick fixes for common security problems in C and C++ and Python, and I think Java as well. It's got a whole bunch of different rules. but it doesn't have any build or release integration, so you can't apply it at a team level. That's kind of rough, because it means that if I install it on my box and I start using it and fixing things, and my manager, Michael, hasn't installed it, and he starts committing code with new issues, I'm going to start seeing his issues pop up in my thing, and I become the person who I become Everett, the person who fixes static analysis bugs, and no one wants to be the one person on their team fixing these bugs. So as a consequence, DevSkim isn't really all that often used, which I think is a really kind of a shame, because it's a powerful tool. Let's talk about false positives. Exactly what people say is a false positive really varies, but I'm gonna take a rather hard stance. If your tool result doesn't provoke an action, it's a false positive. I don't care if you found a SQL injection vulnerability. I don't care if you have found an information leak or an authentication bug. If you report that to the developer and they don't fix it, you're wasting time. Your time, computer time, the developer's time, everyone's time. Therefore, a result without an action is a false positive. This is a really easy way to differentiate them. Now, that result may have no action because of documentation issues. That result may have no action because of management chain issues where their management doesn't care to fix bugs. But that doesn't matter. The nice thing about this, though, is that this is really easy to monitor and measure. So, you know, you avoid wasting developer time. You don't have arguments about what is and isn't a false positive. It's a false positive if they didn't take an action on it. And it's really easy to measure in a way that measuring at scale whether or not you're reporting true or false positives is really difficult if you're using a more conventional definition like, is there a real bug here? So yeah. Tool rollouts matter. Let's say you've built a tool. You've done everything right. It's simple. It's fast. It integrates into the PR experience. It integrates into the it integrates into build. It's, you know, you're ready to have it run everywhere. It only reports true positives because you're some sort of space wizard who has beaten the halting problem. Like, are you ready to just roll it out? It turns out no. Tool rollouts really matter a lot in this world. You don't get a redo on a first impression. So you really need to think about false positive rates in developer psychology. Look, developers are the ones who fix bugs. I mentioned this earlier, but if they don't trust your tool, they're not going to pay attention to the results. There's this false positive noise cycle where if the first set of results that you report as a tool, if, you know, all right, I'm gonna make a confession. Even as a tool developer and someone who, you know, runs these tools pretty often, if I go down the list of results and I look at 10 of them and they all seem to be junk to me, I'm gonna stop running your tool unless someone comes and tells me that I absolutely must. And even if I absolutely must, I'm gonna stop paying attention to the results as in depth. So if you say, hey, this 30 function path may have a SQL injection vulnerability, I'm going to take a cursory look at it, but I'm not going to spend the 20 or 30 minutes stepping through all of the code to make sure that you're right or wrong. If it looks right, I'll fix it, and if it looks wrong, I won't. And that's just kind of true of a lot of things. Another thing is bug overload. If you report 1,000 bugs, people are just going to ignore them. One option is to offer baselining capabilities. The idea there is basically, rather than fixing everything in a legacy code base, you basically say, hey, we're only going to fix new things going forward. And that makes a lot of sense. Changing code is risky and may introduce security vulnerabilities. Changing old code that's been running for a long time is even riskier. So because of all of this, I really recommend you take the frog in a pot approach to tool rollouts. You want to roll out slowly. You want to make sure that as your tool starts getting adoption, you only roll out a couple checks at a time, and give people a chance to go fix those before you start turning on more. This gives developers a chance to build trust in your tool. This gives people a chance to really get an idea of what the bugs look like, and really it sort of allows you to build the virtuous cycle version of the false positive cycle that I mentioned before, which is basically, hey, you reported a couple good results, so I'm going to pay more attention to your new results. And even if you report a couple false positives because you have one noisy check, that doesn't necessarily mean that all of your results are junk and that I'm going to ignore all of them. So, tale of two tools. Let's talk about some tools for finding credentials. Now, this is a pretty common problem. Credentials in source. Red teams love them. Blue teams hate them. If you're checking credentials into your source, please don't, unless you really want to make friends with the red team. There have been multiple attempts at solving this problem at Microsoft. There was one tool that was, reasonably. It was actually a pretty good tool. It found everything. If there was a credential of really any sort in your source code, it identified it. That was great, except for the fact that it was really noisy. And so 6 months later, another tool came along with way fewer checks. It had only like 5 or 6 different checks compared to 30 or 50 in the first tool. And yet, the second one wound up becoming the wildly successful credential scanner tool that I mentioned earlier. It's now running, 9 million times a day. And the first tool, which hit the Microsoft internal, but hit the market sooner, excuse me, has sort of languished in obscurity and just been completely overtaken by this tool that now catches about as many things. But because no one wants to go fix 5,000 things, or no one wants to go fix even 100 things, the second tool, which gave a much more manageable number of bugs initially, became much more successful. So let's talk about onboarding costs. The more expensive, this seems really obvious to me, but the more expensive it is to onboard your tool, the less likely people are to do it. If I need to dance in a circle in my team room while muttering arcane rituals before downloading an executable off of a share from a machine under someone's desk in another state, then that's probably not going to happen. Well, partly because I'm in an open team room, and let's be honest, my teammates would probably find demonic chanting a little worrisome. But glibness aside, if you can get your integration story in line before you do the rollout. Ideally, people just have to check a box, or it's completely automatic. If you can just apply the policy to everyone, that's going to be way, way more effective than asking everyone to go check a box, which is then going to be way more effective than asking everyone to go modify their builds. My team is actually working on something with this right now. we've been shipping a Microsoft internal feature that basically looks at credentials during Git pushes, and at the moment you have to flip a switch on your repository to go turn this on, and we would really like to be able to just have it turn on automatically for everyone, because quite frankly, people don't go flip that switch. Let's talk about support and update story. This is really post-rollout, but you should be thinking about it from when you first get started. Updating tool versions is just such a painful problem for so many tools, unfortunately. Look, if your tool is going to start outputting things in a new format, or if your tool is going to change, even just changing its command line arguments dramatically, that will keep people using the old version of the tool. So think really deeply about when you're designing your tool and as you're rolling it out, how you're going to keep people on the latest and greatest. Because otherwise, people will fall behind. Anecdotally, there was an 8-year tool upgrade gap for a large product at Microsoft between, they were running the tool and the security checks didn't change dramatically, but some of the usability checks and accessibility checks had been added, and it took them 8 years to update to the latest, which was several releases. So yeah, and then also just make sure you have a tool support story. Like ideally that's an alias that people can email or something like that, but there's going to be, I've run into this with BinSkim, there's going to be some weird edge cases. It turns out that Xamarin ships, if you build an application with Xamarin, that ships as a PE executable to an iOS device, which is insane to me. So exactly how ASLR on iOS and ASLR in a PE file interact is going to be really, that's something I had to go research, and I still don't have quite the right answer, I think. But if you're writing a tool that looks at PE files, you're probably not going to have thought about that case when you initially wrote the tool. So have a place people can go ask questions. Let's talk about tool update panes. So FxCop, or Visual Studio Code Analysis for those who aren't internal to Microsoft, is a C# static analysis tool. Roslyn, or the Roslyn static analyzers, is the new .NET, so Roslyn's the new .NET compiler. The Roslyn static analyzers are the static analysis stack for it. These are both static analysis tools. Roslyn was a complete rewrite of the compiler, and the Roslyn static analyzers were a complete rewrite of the FxCop checks. The rules at the moment are about the same. Excuse me. Still recovering from a cold I had last week. Something's been going around. So the real pain here is that the integration points for these two are different. FxCop allows you to, FxCop basically looks at the managed IL and decompiles it and runs static analysis checks on it, whereas the Roslyn static analyzers require you to integrate into the build. That one small change has led to a huge number of teams not updating to the Roslyn static analyzers, despite the fact that FxCop is slowly losing compatibility for newer .NET features. And the Roslyn static analyzers has been available for several years at this point. And honestly, all of these things, all of this rollouts matter. It's about scaling. Microsoft scale is huge. Your customers may not be quite as large as a Microsoft team, but here's a fun number. When FxCop was first rolled out on the Windows Vista codebase, it added 8 hours to the build, and that's a huge amount of time. Turns out there wasn't all that much C#, so why it was adding 8 hours to this build was hard to figure out. But they went in and debugged it and realized FxCop takes 1 or 2 seconds to start up. And they were running it on every DLL and EXE, which means all of these non-managed DLLs and EXEs were getting, there was a 1 or 2 second spin up. I'll look at the DLL or EXE saying, hey, this isn't managed code, and FxCop would shut down. That alone on 30,000 binaries added 8 hours to the build. Now, that would be a much shorter time in a modern parallelized build environment, but that kind of scale is just huge. So we're talking about millions of pushes a week, millions of builds a week, et cetera. If you don't have developer trust and you're trying to get to that scale, people are just going to turn you off if they can. People are just they're gonna route around things that impair their productivity. So you absolutely need to make sure that you follow the sort of rollouts matter stuff, because all of this is about getting things to scale. And yeah, let's talk about BinSkim, which I believe to be a mostly successful tool. I am biased. I wrote it. Well, wrote some of it. This checks for compiler hardening. It looks at ELF and PE binaries, says, hey, did you compile these with ASLR enabled? Did you compile these with control flow guard on Windows? Or actually, I haven't implemented that yet. I was going to say Clang's control flow guard equivalent, but I haven't actually implemented that check. I need to go do that. This is a tool that's reliable enough that people put it into their build and break their build on it. That's about as good as you can get in this land, because that puts you on par with a compiler, which people really do trust the results from. So all of that being said, our documentation could use some work. I answer a question about once a week about whether or not managed code and high entropy VA interact well. You should be turning high entropy VA on your managed code on. So, documentation isn't great. I've been working on that. But yeah, questions?